Not long ago, I wrote a paper in which I argued that large language models are not merely statistical next word predictors, but that they can develop a form of operational understanding. The ability to manipulate concepts and structures in such a way as to produce new, verifiable, and useful results. Now, what happened? That thesis was rejected brutally, a desk rejection accompanied by a scornful comments as if it were a scientific heresy. I was told that I was mistaking a stochastic generator for a thinker, that it was nothing more than a linguistic illusion. Moreover, in June this year, Apple published a paper titled The Illusion of Thinking, arguing that large reasoning models, systems designed to reason through detailed chain of thought, experience an accuracy collapse once task complexity rises beyond a certain threshold. In practice, they fail to maintain coherence and reasonability even on tasks that are only moderately complex. And today, with the new case of GPT-5 proving a new and previously unknown mathematical theorem, we have an empirical evidence that this is not always the case. AI can indeed reason and produce operational knowledge, even when prevailing thesis attempts to delegitimize it. This result profoundly undermines the narrative of the stochastic parrot, and it confirms that the idea I had tried to defend in my paper, that of the operational understanding emerging bottom-up, which of course is an operational understanding which is different from our own, but it is indeed real. It was not a delusion, it was merely ahead of its time. What happened exactly in this experiment? Sebastian Bubeck of Microsoft posed a challenge to GPT-5 Pro, an open problem in convex optimization known to the mathematical community but not yet satisfactorily solved. How did things go? In 17 minutes, the AI produced a new proof, improving the known bound from 1/L to 1.5/L, a proof that was verified and confirmed correct, never published in any paper, nor available in the training data. In short, it was unprecedented. In the days that followed, human mathematicians pushed the result a bit further, up to 1.75/L. But the point is this: the first step was taken by a machine. If artificial intelligence were just truly a parrot, incapable of going beyond the repetition of patterns, how can this event be explained? How can you explain it? A parrot does not prove a theorem. A parrot does not construct a coherent deductive chain in an abstract and formal mathematical domain. Here we are faced with something that cannot be dismissed as mere imitation. It is the new production of knowledge, the very core of what we call intelligence. The expert Ernest Ryu noted that the result is not revolutionary. All right, I accept that. A good PhD student in optimization could have reached it in a few days. That's true. But this is exactly the point where the paradigm shift becomes visible. GPT-5 achieved it in minutes, not in days. In science, in engineering, speed is not a detail. Reducing a process from days to minutes multiplies the possibilities of exploration, allowing the pursuits of paths that human researchers would never have the time to explore. a PhD student is intelligent even if they don't discover the general relativity. They are intelligent because they solve new problems. In the same way, an AI that produces a correct proof operates within the same operational definition of intelligence. So, believe it or not, those are the facts. The metaphor of the stochastic parrot was born with the early language models, GPT-2 and GPT-3, which indeed appeared as sophisticated statistical predictors. But come on, give me a break. You cannot continue to say the same thing with GPT-4 and GPT-5. We are witnessing a qualitative leap. The models display capabilities out of distribution generalization, multi-step reasoning, and the production of formalizable and verifiable results. To still call them parrots is a categorical error. It's like saying that an airplane doesn't really fly because it merely imitates the flight of birds. We define intelligence as the ability to solve new problems in complex context. This is the definition used in cognitive science, in psychology, and computer science. In this light, AI has demonstrated intelligence, not because it understands like us, but because it generates new, functional, coherent solutions. The fact that it lacks consciousness or emotions does not detract from its operational intelligence. Now, what is my conclusion? The question is no longer whether AI is intelligent, but what kind of intelligence is emerging. It is not human intelligence, nor biological intelligence. It is a new form of intelligence. Let's call it, hybrid, capable of standing beside us in the production of knowledge. To keep speaking of a stochastic parrot is now reductive, almost ideological, almost religious. Because if a machine proves a new theorem, then the question is not whether it is intelligent, but whether we are ready to accept that intelligence can exist in forms different from our own. And perhaps this is precisely where the true scientific and epistemological revolution begins. The history of science teaches us that every time a new tool extended our cognitive capabilities, from the telescope to the computer, we had to redefine what it means to know. Today, with artificial intelligence, we are redefining what it means to be intelligent.